Today we are going to discuss some. Hello, good morning. Today we are going to discuss MCQs and graph. Okay. Now see here, which of the following statement for a simple graph is correct? Which of the following statement for a simple graph is correct? That is, each path is a trivial path. Each path is a trivial path in the sense what? Only one vertex is there, then we can call it as a trivial path. That means there is no path from that path, only one vertex is exists, then we can call it as a trivial path. Okay, here every path, every trivial is a path, and every trivial is path as well as every path is trivial. And next path and trivial have no relation. So here a walk, that means answer is A. Now the answer here A. Here answer A. Answer is A. So A అనేది ఏంటి అంటే that is every path is a trivial path. Means see here explanation, that is, if in a walk, if the vertices are distinct, it is called a path. Okay, suppose for example you can observe here, this is a figure. In this figure here A to B some path is there and B to D some path is there. Okay, and suppose here you can observe A, B, C, D, E is one path. That means all the vertices are distinct here, then we can call it as a path. Whereas if the edges are distinct, it is called trial. అంటే ఎడ్జెస్ కనుక రిపీటెడ్ అయింది అనుకోండి, అంటే పాత్ అని అంటే ఒకవేళ ఈ వాక్లో కనుక మనకి ఇవి డిస్టింగ్ వర్టిసెస్ డిస్టింగ్ ఉంటే దెన్ వీ కెన్ కాల్ ఇట్ యాజ్ ఏ వాట్ trial, that is, in this 1 2 3 4 here A B C E. So observe this path, here vertices are different, then this is called as what? Then this is called as path. Whereas if the edges are distinct, suppose for example here in this case you can observe here A to B, B to D and D to A. D to A. That means here uh, uh, and A to, again this A to B is there. Okay. Now A to B is there, B to D is there, D to A is there. Okay. In this case also this is called as what? Trial. Edges are different. A to B is different, B to D is different, D to A is different. Okay. And suppose you can observe here again A to B, again A to B, next B to C, next C to E. So this is not a walk as well as not it is not a walk, but it is a trial. ఎందుకు ఇది వాక్ కాదు? సపోజ్ యూ కెన్ అబ్జర్వ్ హియర్ A to B some path is there, some edge is there, from B to D some edge is there, B to A edge is there, again A to B edge, next B to C edge, C to E edge. Okay, here you can observe this is not a walk because it is not a path because A is repeated twice, A to B, B to D, D to A, again A to B. So this is not a what? Not a path. And coming to the trial, means edges distinct undali. So edges distinct means, suppose you can observe here A to B, B to D and D to A, again A to B, again A to B, then B to C. So again here this is not a not what and is, that means it is not a edge, that sorry not a trial. Means what? Every path is a trial, but every trial is a path. Every trial అనేది path కాదు, every path is a trial. Suppose A B B C C E, so this is the path, this is a trial. Here edges also distinct. Suppose coming to here in this case, suppose you can observe here A to B and B to D and D to A. Suppose observe here, this is what? This is not this is a trial. Suppose ఇది కూడా తీసుకున్నాం అనుకోండి, this is not a path as well as not a trial. Suppose you can observe here E to C, C to B and B to A, A to D, next D to B, okay, next B to A. So suppose you can observe B to A. So this is in this case here A to C, C to B, B to D and A to B. A to B. సో ఇలా అబ్జర్వ్ చేసామనుకోండి అప్పుడు ఏమవుతుంది ఇది మీకు ట్రయల్ అవుతుంది బట్ వాక్ కాదు ఓకే వాక్లో పాత్లో ఏంటి అంటే వర్టిసెస్ డిఫరెంట్గా ఉండాలి ఎడ్జెస్ డిఫరెంట్గా ఉంటే దాన్ని ట్రయల్ అంటాం ఓకే ఇక్కడ ఎవ్రీ పాత్ ఈజ్ ఏ ట్రయల్ ఎవ్రీ పాత్ కూడా ట్రయల్ అవుతుంది సపోజ్ యూ కెన్ అబ్జర్వ్ హియర్ ఫ్రమ్ హియర్ 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 దిస్ ఈజ్ సమ్ పాత్ సో దిస్ ఈజ్ ద ట్రయల్ బికాస్ ఆల్ ద ఎడ్జెస్ ఆర్ డిఫరెంట్ but every trial is not a path every trial is not a path suppose you can observe here this is and this is next from here to here here to here here to here here to here so this is what repeated so this edge is repeated that's why this is not a path so every trial is a path as well as every path is a trial so not vice versa only every path is a trial okay here in the given graph identify the cut vertices so first of all what is the cut vertex write down the definition for this cut vertex suppose you can remove any vertex from the graph that can be divided into number of components so now it is single component you can observe here this is a single component suppose you can remove this vertex now in this case only A to D is one edge is there and C to D, C to E one edge is there. There is no edge from B to C as well as B to D as well as B to A. So that automatically ఏమవుతుంది మనకి this is removed. So this one is removed. Okay. So this is the concept of cut vertex. Okay. Here in the given graph identify the cut vertices. That means అలాగా B is one cut vertex and one more cut vertex is there that is what C is also cut vertex that means suppose you can remove this one అంటే సపోజ్ B రిమూవ్ చేసాం ఆటోమేటికల్గా A to D ఉంది C రిమూవ్ చేసాం అనుకోండి A to D and E సో దిస్ ఈస్ వాట్ దీస్ టూ ఆర్ ద కట్ వర్టెక్సెస్ దట్ మీన్స్ మ్యాక్సిమం మనకి ఇక్కడ అబ్జర్వ్ చేస్తే హియర్ after removing either B or C a graph becomes disconnected అంటే గ్రాఫ్ ఏమవ్వాలి మనకి డిస్కనెక్ట్ కావాలి సపోజ్ ఇక్కడ ఏ రిమూవ్ చేసాం అనుకోండి గ్రాఫ్ డిస్కనెక్ట్ అవుతుందా అవదు సో B to D to B edge is there B to C edge is there and C to D C to E edge is there so that the graph is not disconnected suppose you can remove this one here also graph is not disconnected from A to B and B to C C to E graph edges are there so that this is connected graph avutundi suppose you can remove this E here also C to B B to A to D and D to B so some connected graph is there that's why and then whenever we can remove any vertex from the graph that can be make it as disconnected so that can be make it as disconnected then we can call that vertex as cut vertex అంటే గ్రాఫ్లో నుండి ఒక వర్టెక్స్ మనం రిమూవ్ చేసినప్పుడు ఆటోమేటిక్గా దాన్ని ఏమవ్వాలి అంటే దట్ కెన్ బి కన్వర్టెడ్ ఇంటూ డిస్కనెక్టెడ్ గ్రాఫ్ ఓకే సపోజ్ యూ కెన్ అబ్జర్వ్ హియర్ అదర్ దాన్ దిస్ B and C suppose you can remove A even though this graph is connected okay from D to B B to C C to E connected is there suppose you can remove D even though this is connected A to B B to C C to E suppose you can remove this one again this is also connected so some connection is connected component is existed so coming to B and C suppose you can remove this B A to D is one connected component and C to E one connected component suppose you can remove this C E is one connected component and A, D, B is one connected component. So that here some connected components are there. Whereas in B, other than this B and C, any one of the vertex is removed from this. This is not disconnected. So that's why B and C are called as disconnected cut vertexes because After removing this either B either C, automatically the graph can converted into disconnected. Okay. Now for this graph, which statement is true? Here for this graph, which statement is true? For this graph, which statement is there? True. That means G is a complete graph. Suppose what is a complete graph? So from one vertex to remaining all the vertices, there is exists some edge, then we can call it as a what? Complete graph. Otherwise, this is not a complete graph. That means from A to B, some edge is there, and C is some edge is there. There is no edge from A to D as well as A to E. That means remaining, suppose you can pick one vertex, remaining all the vertices are adjacent to this vertex, then we can call it as a complete graph. So that this is not a complete graph. And G is not a connected graph. No, it is a connected graph, not a connected graph kaadu. It is a connected graph. That means you can observe from any vertex to other vertex, you can have some path. That's why this is a connected graph. The vertex connectivity of the graph is 2. Suppose you can observe here any vertex, that means uh, any vertex, here this is 2, here 2, here 2, here 2. Okay. Now the edge connectivity of the graph is 1. Now see here, after removing the vertices B and C, the graph becomes disconnected. That means vertex connectivity and edge connectivity nothing but apply the cut vertex and cut edges. Cut vertex కానీ cut edge apply చేసినప్పుడు ఎన్ని components ఉంటాయి? That means total గా how many number of components are there? For example, you can remove here B and C. B and C. Here how many number of that means B and C. Remove from this vertex from B and C. Here A is and D and E. That is the vertex connectivity of the graph is 2. Here the edge connectivity of the graph is 1. This is not true, false statement. The vertex connectivity of the graph is 2. That means suppose you can remove this B. Suppose you can remove this B, A to C and C to E and C to D is there. So this is one connector. Suppose you can remove this C, now A to B, B to D and B to E. That means 2 connected components are there. Okay. Next, what is the number of edges? What are the number of edges presented in a complete graph? How many number of edges untai complete graph lo? So based on this you can identify, that is n into n minus 1 by 2. That means for example here the graph is like this. Suppose here you can observe this is some graph. So from here to here, from here to here, from here to here, from here to here. Next. Here. Now this is A, this is B, this is C, this is D and this is E. 5 vertices are there. Now how many number of edges are there? 1, 2, 3, 4, 5. Now it is 6, it is 7, it is 8 and 9. Next 10. Total how many number of edges are there? 10 edges are there. That means how many number of vertices are there? 5. And total degree of this, total sum of degree of these vertices is what, Annie? Sum of degree of these vertices is what? For every vert. Now it is called as a complete graph. That means you can take the vertex A, remaining all the vertices are adjacent to this A. Now the degree is 4 here, here the degree is also 4, here degree 4, here degree 4, here also degree 4. The sum of degree is what, only 20. Sum of the degrees is 20. But number of edges, this is the undirected graph, means here edge from A to B is same as B to A. That's why total how many number of edges are presented. So that means degree is 20, okay. That is n into n minus 1 is the degree. That is n into n minus 1 is nothing but 5 minus 1. 5 into 5 minus 1 divided by 2. 5 into 5 minus 1 means total how the sum of degrees is. That means 5 degrees sum. 5 into 4. Each and every degree vertex, each and every vertex degree is 4. That's why 5 into 4 nothing but 20. Means 5 into 5 minus 1. So number of edges is divided by 2. That means total edges are 10. Now move to here. What is the answer for this? This is n into n plus 1 by 2. Not correct. That means 5 into 6 divided by 2. That is 15. But here only 14, only 10 edges are there. Okay. Now move to second option, n into n minus 1 by 2. Yes. N into n minus 1 by 2. That is nothing but n into n minus 1 nothing but 5 into 5 minus 1 divided by 2, 4. That is 10. And n is nothing but this is the correct statement. N is nothing but if it is the diagram, that is the simple graph. In that case, there exists, if it is a complete graph, there exists n number. That means what? Here from here to here some graph is edge is there, from B to A edge is there, both directions edge is there. Then the total number of edges are 20 and sum of degree is also 20. Okay, here also sum of degree is 20, but uh, concept is what? This is undirected graph, nothing but, so that we can see from A to B and B to A both are same. Next question. So that answer is B. Now the answer is B. Answer B. Now see the next question, that is see here, number of ways in which every vertex can be connected to each other is, this is also one of the formula. NC2 is the formula, otherwise n into n minus 1 by 2 is also formula as your wish. And the given graph is the regular graph. So this is the regular graph, means you can observe every vertex degree is same. Every vertex degree is same, then we can call it as a regular. That is every vertex. What is the regular graph? That is every vertex degree is same. Then it is called as a what? Regular graph. Okay. Now you can observe here A degree is 3. 1, 2, 3. And coming to the B degree is 1, 2, 3. Coming to the C 1, 2, 3. Coming to the D 1, 2, 3. For E 1, 2, 3. For F 1, 2, 3. That means now the given graph is regular. Yes, it is regular graph. That means in a regular graph, degree of all vertices are equal. So in the given graph, the degree of vertex is 3. Next question. In a simple graph, the number of edges is equal to twice the number of degrees of the vertices. That means in a simple graph, the number of edges is twice the sum of the degrees of స్ట్రీమ్స్లో క్లాస్ ఇంకా రికార్డ్ స్ట్రీమ్ అవ్వదు అంతే. In a simple graph, the number of edges is equal to the twice the number of degrees of the vertices. That means the sum of the degrees of the vertices is equal to the sum of the in a simple graph in the sense what? There is no self loops and there is no multi graph. That means self loops and multi graphs undakudadu. Then we can call it as a simple graph. That means the sum of the number of edges is equal to the twice the sum of the degrees of the vertices. So this is possible in a regular, that means undirected graph. Okay. That means if the undirected graph, suppose you can observe here, this is undirected graph. Here 5 vertices are there. That means 20 equal to sum of degrees equal to number of edges. That means how many number of edges here? That means sum of degrees equal to twice the number of edges. So this is possible in where? That is in the complete graph only. So this is possible in complete graph only. Okay. That means this statement is possible in the complete graph only, but not in the simple graph. Simple graph means there is a edge from A to B, but that means in the graph there is no multiple edges, as well as there is no simple loops. Then we can call it as a simple graph. Okay, so we concentrate on different types of graphs. That is a simple graph in the sense there is no multiple edges as well as self loops. Then we can call it as a simple graph. Okay, now coming to this, this is the complete graph, means the sum of degrees equal to twice the number of edges, whereas in regular graph nothing but that is not the complete graph, but each and every vertex degree is same. Suppose you can remove this one, here you can remove this one, here you can remove this one, here you can remove this one. Now you can call it as a simple graph, call it as a regular graph, but not the complete graph. Complete graph ki simple graph ki regular graph ki difference enti? Complete graph lo compulsory every adjacent vertex toti edge anedi form avutundi, ante remaining vertices తో కంపల్సరీ ఎడ్జ్ అనేది ఉంటుంది. అది మనకి రెగ్యులర్ గ్రాఫ్ అంటే ఏంటి? సో ఎవ్రీ గ్రాఫ్ లో మనకి ఈక్వల్ ఎవ్రీ గ్రాఫ్ లోని ఏ వర్టెక్స్ తీసుకున్నా కూడా ఈక్వల్ డిగ్రీ ఉంటుంది. దెన్ ఇట్ ఈస్ కాల్డ్ ఎస్ ఏ రెగ్యులర్ గ్రాఫ్. But what about the simple graph? There is no self loops. That means it is a regular graph as well as simple graph, because there is no multiple paths between these two, as well as there is no self loops. That means edge exists itself is called as a self loop. That means from D to D edge undi anukondi, that is called as self loop antam. Ante self loops levu, alage multiple edges levu. Then we can call it as what andi? It is a simple graph as well as regular graph also. Okay, now the sum of degrees of the vertices equal to the twice the number of edges. Twice the number of edges. Here in a simple graph, the number of edges is equal to twice the sum of the degrees. This is the problem. And but simple graph is nothing but complete graph as well as regular graph. Okay, simple graph అనేది ఏంటి? మనకి కంప్లీట్ గ్రాఫ్ కావచ్చు, రెగ్యులర్ గ్రాఫ్ కావచ్చు. బికాస్ ఆ రెండింటి మధ్యలో మనకి మల్టిపుల్ ఎడ్జెస్ ఉండవు, అలాగే సెల్ఫ్ లూప్స్ ఉండవు. కాబట్టి రెగ్యులర్ గ్రాఫ్ కానీ కంప్లీట్ గ్రాఫ్ కానీ సింపుల్ గ్రాఫ్ అవుతుంది. బట్ ఓకే, సింపుల్ గ్రాఫ్ అవుతుంది. సో దట్ స్టేట్మెంట్ ఏంటి ఇక్కడ? ద సమ్ ఆఫ్ ద డిగ్రీస్ equal to the twice the number of edges, but here number of edges equal to the twice the sum of degrees. So that statement is false. and a connected graph with 6 vertices and 7 edges. That means v minus number of vertices, v number of edges plus number of regions, v plus e plus r equal to 2. Yesterday this formula v minus e plus r equal to 2. So this is the formula. This is the Euler's formula. This is also called as Euler's formula. That means if the graph is Eulerian graph, we can apply the Euler's path. That means Euler's graph అని ఎప్పుడు అంటామంటే that is the planar graph అయి ఉండాలి. What is the planar graph? There is no crossovers. Means suppose you can observe here, this is some crossover is there. Okay, so ఇలా క్రాస్ ఓవర్స్ లేకుండా మనం గ్రాఫ్ కనుక చేయగలిగితే దట్ ఈస్ కాల్డ్ ఎస్ ఎ ప్లేనార్ గ్రాఫ్. అదర్వైజ్ దిస్ ఈస్ కాల్డ్ ఎస్ ఎ నాన్ ప్లేనార్ గ్రాఫ్ బికాస్ హియర్ సమ్ crossover is there. From B to E some edge is there, D to C one edge is there, some crossovers are there. So to remove this crossover, there is a chance here from B to E you can take like this, from B to E some edges like this. Now there is no crossovers. This graph is also planar graph. Okay, in the planar graph how many number of regions are there? That is depends on the number of vertices and number of edges. Suppose you can observe here, from here to here, here to here. So this is one region and this is one region, and now this is one region. Now here to here one region. So like that number of regions are there. Here how many number of vertices are there? 6 vertices are there. And coming to the edges, how many number of edges are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Suppose you can observe here how many number of vertices? From A 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 edges are there. But ikkada on question lo em achadu manaki 6 vertices and 7 edges, means number of vertices are 6 and number of edges are 7. Then how many number of regions are there? That means we have some Euler's formula. Number of vertices are 6, number of edges are 7, plus r equal to 2, means r equal to 3. That means how many number of regions are there? 3 regions are there. So ఇక్కడ మనకి ఇక్కడ అబ్జర్వ్ చేశారనుకోండి ఎన్ని రీజన్స్ ఉండొచ్చు అంటే ఫస్ట్ మీరు 6 vertices ఉన్నాయి, 1 2 3 4 5 6 7 8 9 9 edges ఉన్నాయి. దట్ మీన్స్ 6 minus 9 plus 6 minus 9 plus r equal to 2, means how many number of regions are there? 5 regions are there. Here 5 regions are there. So these 5 regions లో మనకి ఎలా ఉన్నాయో చూడండి. Now observe here, this is one region. A, B, C is one region. Now here B to E, B to E, E to F and F to A. A to C, C to B. One region is there. Okay, now you can observe one more region, that is D to C. Okay, and C to A, C to F, and here one region is there. Now you can observe one more region, 3 regions are completed. One more region D to E, E to F and F to D. One region is there. Now you can take this one here from edge from B to E, so that B to E edge is there. Next E to, okay, B to E's edge is there. Now E to F edge is there, F to D edge is there. So that again one region is there. Like that here 5 regions, that means 4 internal regions and 5 one more is outside ఏదైతే ఉంటుందో that is the external region. Each and every graph కి ఒక external region ఉంటుంది. Internal regions వచ్చేసి 4, that means A, B, C, this is one internal region. Now B, E, F, A, C, B, this is one region, and from B, C to B, B to E, E to F and F to D, one region, and B to E, E to F, and next D to E, next E to D to C, C to B, and this is one region. So మీరు ప్లేనార్ గ్రాఫ్ కి కన్వర్ట్ చేసిన తర్వాత అబ్జర్వ్ చేసి చూడండి, హియర్ టోటల్ గా మనకి 5 రీజన్స్ వస్తాయి. 4 internal regions, ఒకటి external region వస్తుంది. So this is the formula. So this is the formula as well as this is also formula. Okay, next question. So if a simple graph G contains n vertices and m edges, the number of edges in the graph G complement. G complement nothing but enti ante. First of all, see here what is the complement. Suppose here the graph is like this. This is some graph A, B, C, D. So this is some graph. Suppose I am write the complement for this one, that is A, B, C, D, and from here to here and here to here. Now this is the complement. అంటే ఇక్కడ edges ఏవైతే లేవో ఆ edges ని ఇక్కడ తీసుకున్నాము. Now this is called as complement of this one. Now observe here what is the question, that is if a simple graph G contains n vertices and m edges, the number of edges in the graph G complement contains how many number of, that means NC2 minus number of edges in G. That means here NC2 nothing but here 4 C2. What is the formula for this? 4 factorial divided by 2 factorial into 4 minus 2 factorial nothing but 2 factorial. That means what any? 4 into 3 into 2 factorial, here 2 factorial. So 2 factorial and 2 factorial is completed. Next 2 factorial nothing but 2. Okay. 2 into 1 is nothing but 1. Now 2 into here 2. So total how many number of edges are there here? 6 edges are there. So ఇక్కడ 6 edges ఉన్నాయి NC2లో, అండ్ ఇక్కడ ఎన్ని ఉన్నాయి టోటల్ ఎడ్జెస్, అంటే టోటల్ గా పాసిబుల్ ఎడ్జెస్ ఆర్ 6. బట్ ఇన్ దిస్ గ్రాఫ్ హౌ మెనీ నెంబర్ ఆఫ్ ఎడ్జెస్ ఆర్ దేర్? 4 ఎడ్జెస్ ఆర్ దేర్. సో కాంప్లిమెంట్ గ్రాఫ్ లో ఎన్ని ఎడ్జెస్ ఉంటాయి? 2 edges ఉంటాయి. That means A to D and B to C. So you can observe here in the complement 2 edges are there. So this is the formula. That means NC2 minus number of edges in graph G. Number of edges in graph G. Now this is the formula. How many number of edges are there in the గ్రాఫ్ లో మనకి ఎన్ని ఎడ్జెస్, అంటే కాంప్లిమెంట్ గ్రాఫ్ లో ఎన్ని ఎడ్జెస్ ఉన్నాయి అనేది ఎలా ఫైండ్ అవుట్ చేసామంటే NC2 మైనస్ నంబర్ ఆఫ్ ఎడ్జెస్ ఇన్ G. ఓకే, సో అదే సేమ్ కాన్సెప్ట్ ని ఇక్కడ ఇలా అడిగాడు. దట్ ఈస్ n into n minus 2 m divided by 2. So first of all you know the answer for this. అంటే G కాంప్లిమెంట్ లో ఎన్ని ఎడ్జెస్ వస్తాయి ఫస్ట్ మీకు తెలిసి ఉండాలి. సో ఆఫ్టర్ దట్ యూ కెన్ అప్లై దీస్ 4 కాంబినేషన్స్. ఓకే, దట్ ఈస్ here for example, suppose we are take only 4 vertices, that means 4 into 4 minus, now see here 4 into 4 16 minus 4, what is the given option here? 4 minus 2, what is that? Minus 2. Now see here 4 into 4 16 minus 4. Okay, 16 minus 4 minus 2 into m. How many number of edges are there here? That means in this graph 4 edges. Suppose మనం డ్రా చేసుకున్న గ్రాఫ్ లో ఎన్ని ఎడ్జెస్ చెప్తున్నాము? 4 edges చెప్తున్నాం. That means here 4 into 4 16 minus 4 minus 2 into 4. So what? 8. Okay, 16 minus 4 16 minus 4. Okay, 16 minus 4 in the sense what? 12 minus 8. 12 minus 8 means 4 divided by 2 nothing but 2. 4 divided by 2 nothing but 2. So now the answer is 2. So that answer is A. So ఇంకా మీకు ఫస్ట్ ఆప్షన్ మ్యాచ్ అవ్వలేదు అనుకోండి, నెక్స్ట్ ఏం చేస్తారు? ఇది ఫైండ్ అవుట్ చేస్తారు. దట్ మీన్స్ 4 plus 4 20 plus 8 28 divided by 2. that is wrong. So like that you can apply, but we got the answer at option A. సో ఇది ఫైండ్ అవుట్ చేయాలి అంటే ఫస్ట్ మనకి ఎన్ని కాంప్లిమెంట్స్ ఉన్నాయో అంటే కాంప్లిమెంట్ గ్రాఫ్ లో ఎన్ని ఎడ్జెస్ ఉండాలో తెలియాలి. సో తెలియాలి అంటే దిస్ ఈజ్ ద ఫార్ములా. దట్ మీన్స్ కాంప్లిమెంట్ అంటే టోటల్ గ్రాఫ్ లోని టోటల్ నంబర్ ఆఫ్ వర్టిసెస్ మైనస్ ఎడ్జెస్ ఇన్ ద graph. How many number of edges in the graph? Okay, number of edges in the complete form of graph. Complete form of graph means in the complete graph లో possibility ఎంత ఉంటుంది, NCT ఉంటుంది. మనకి ఇచ్చిన ఎంత అంటే టోటల్ నెంబర్ ఆఫ్ పాసిబిలిటీస్ మైనస్ గివెన్ నెంబర్ ఆఫ్ ఎడ్జెస్, దట్ ఈస్ నథింగ్ బట్ కాంప్లిమెంట్ గ్రాఫ్ లో ఉంటాయి. సో ఇక్కడ మరి అప్లై చేసేసి దాన్ని యూ కెన్ గివ్ ఇట్ యాజ్ ఏ ఆన్సర్. నౌ ద ninth question. Here, which of the following properties does a simple graph not hold? That means must be a connected. It must be a connected. Compulsory connected graph ayi undali. So must be a unweighted. So unweighted అవ్వాల్సిన అవసరం లేదు, weights ఉండొచ్చు. Must have no loops or multiple edges. అంటే must have no loops or multiple edges. రెండు కూడా ఉండకూడదు. That means must have no loops and multiple edges. That's why this statement is also false. And must have no multiple edges. Must have no multiple edges. That is must have no multiple edges. Means there is no multiple edges. That means a simple graph may be sorry ఇక్కడ ఏమన్నాడు మనకి నాట్ అన్నాడు. సారీ see here not hold అన్నాడు. ఓకే నాట్ హోల్డ్ అన్నాడు అంటే మస్ట్ బి ఏ అన్వైటెడ్. సో ఇట్ బి ఏ ఓకే సపోజ్ ఇక్కడ దిస్ ఈస్ అబ్జర్వ్ హియర్, దిస్ ఈస్ ఎ సింపుల్ గ్రాఫ్, దిస్ ఈస్ అన్వైట్స్, దెర్ ఈస్ నో వెయిట్స్. ఓకే ఇట్ ఈస్ ఏ కనెక్టెడ్ ఆర్ డిస్కనెక్టెడ్. మీన్స్ సపోజ్ ఇక్కడ మనకి సి రిమూవ్ చేసామనుకోండి, ఇప్పుడు ఇది ఏమవుతుంది, డిస్కనెక్టెడ్ అవుతుంది. మీన్స్ ఏబి అండ్ ఏఎఫ్ ఈజ్ దేర్ and there is no graph from D to F. అంటే ఇక్కడ ఏమవుతుంది, సపోజ్ సిని కానీ సి అండ్ ఈ రెండు రిమూవ్ చేసామనుకోండి, ఆటోమేటిక్గా మనకి ఏమవుతుంది, గ్రాఫ్ అనేది డిస్కనెక్ట్ అవుతుంది. లైక్ దిస్ how it is possible? Suppose I can remove the vertices from here C D E. C D E రిమూవ్ చేసాం. సో అక్కడ ఏమవుతుంది మనకి డిస్కనెక్టెడ్. అంటే ఒకవేళ రిమూవ్ చేసినప్పుడు సమ్ టైమ్స్ మనకి కనెక్టెడ్గా ఉండొచ్చు, సమ్ టైమ్స్ డిస్కనెక్టెడ్గా ఉండొచ్చు. ఫర్ ఎగ్జాంపుల్ ఈ సిని రిమూవ్ చేసాం అనుకోండి, అప్పుడు ఏమవుతుంది, ఏబికి కనెక్షన్ ఉంటుంది. అలాగే ఈని రిమూవ్ చేసాం అనుకోండి. ఓకే సో ఇక్కడ ఈని ఎఫ్ని రిమూవ్ చేసాం, అప్పుడు ఏమవుతుంది, ఏబి ఒకటి కనెక్టెడ్ కాంపోనెంట్ అవుతుంది, డి ఒక కనెక్టెడ్ కాంపోనెంట్ అవుతుంది, అంటే డిస్కనెక్టెడ్ అవుతుంది. ఒకవేళ సి ఒక్కటే రిమూవ్ చేసాం అనుకోండి, అప్పుడు ఇది కనెక్టెడ్ కాంపోనెంట్ గానే ఉంటుంది. అంటే సింపుల్ గ్రాఫ్ మే బి కనెక్టెడ్ ఆర్ డిస్కనెక్టెడ్. అండ్ ఇట్ మస్ట్ హ్యావ్ దెర్ ఇస్ నో వెయిట్స్. ఇక్కడ వెయిట్స్ అనేటివి ఉండవు. సో దెర్ ఇస్ నో సెల్ఫ్ లూప్స్ యాజ్ వెల్ యాజ్ దెర్ ఇస్ నో మల్టిపుల్ ఎడ్జెస్. ఓకే దెర్ ఇస్ నో సెల్ఫ్ లూప్స్ అండ్ దెర్ ఇస్ నో మల్టిపుల్ ఎడ్జెస్. సెల్ఫ్ లూప్స్ ఉండకూడదు, మల్టిపుల్ ఎడ్జెస్ ఉండకూడదు. మస్ట్ హ్యావ్ నో మల్టిపుల్ ఎడ్జెస్. సో దట్ మీన్స్ second statement, third statement, fourth statement, all these three are true regarding simple graph. It must be unweighted. Okay compulsory unweighted ayi undali. It must have no loops or no multiple edges. Loops ఉండకూడదు or multiple edges, and must have no multiple edges. So these three properties true. So but simple graph may be disconnected or connected. Now coming to the 10th question. That means what is the number of edges? What is the number of edges in a bipartite graph? Bipartite graph lo how many number of edges ఉంటాయి? So that is bipartite graph lo అంటే what is the maximum number of edges in a bipartite graph? Have 10 vertices. Suppose what is the bipartite graph? Here suppose you can observe here, this is one vertex and these two are the vertices. From here to here edge is there, from here to here edge is there, from here to here edge is there, from here to here edge is there. Now it is called as a bipartite graph. Means divide the vertices into two distinct sets. So this is one set, A and B are some set and C and D are other set. So there is no edges are formed within the same vertices with the vertices in the same set. అంటే సేమ్ సెట్లో ఉన్న వర్టెక్స్ తోటి మనకి ఎడ్జ్ అనేది ఉండకూడదు. ఓకే, ఇలా ఉంటే దీన్ని మనం బైపర్టేట్ గ్రాఫ్ అనం. సో బైపర్టేట్ గ్రాఫ్ ఇన్ ద సెన్స్, so this is called a bipartite graph, means this A and B, C and D. So there is no edge from A to B, there is no edge from C to D. Same set of vertices doesn't have any edges, then we can call it as a bipartite graph. Now one more, this is here one more graph is edge is there like this. This is one vertex. So from here to here and here to here, so ఇక్కడ నుండి ఇక్కడికి మనకి ఎడ్జెస్ ఉన్నాయి. ఓకే, ఇలా ఎడ్జెస్ ఉన్నాయి. సపోజ్ యూ కెన్ అబ్జర్వ్ దిస్ ఈజ్ నాట్ ఏ కంప్లీట్ బైపర్టేట్ గ్రాఫ్. దిస్ ఈజ్ నాట్ ఏ కంప్లీట్ బైపర్టేట్ గ్రాఫ్, మీన్స్ దెర్ ఈజ్ ఏ ఛాన్స్ ఫర్ హియర్ అండ్ హియర్. ఓకే, దెర్ ఈజ్ ఏ ఛాన్స్ ఫ్రమ్ హియర్ అండ్ హియర్, దెన్ ఓన్లీ వీ కెన్ కాల్ ఇట్ యాజ్ ఏ బైపర్టేట్ గ్రాఫ్. అంటే ఒక సెట్లోని ఒక వర్టెక్స్ ఉంది, రిమైనింగ్ ఆల్ సెట్ ఆఫ్ వర్టిసెస్కి ఎడ్జ్ ఉంది అనుకోండి, దెన్ వీ కెన్ కాల్ ఇట్ యాజ్ ఏ కంప్లీట్ బైపర్టేట్ గ్రాఫ్. సపోజ్ ఇలా ఉంది అనుకోండి, సో దిస్ ఈజ్ ఏ బైపర్టేట్ గ్రాఫ్. It is a bipartite graph but not a complete bipartite graph. ఇక్కడ మనకి సపోజ్ 2 vertices ఉన్నాయనుకోండి, ఎన్ని నెంబర్ ఆఫ్ ఎడ్జెస్ ఉంటాయండి? సపోజ్ హియర్ ఎన్ని ఎడ్జెస్ ఉంటాయి? 4 ఎడ్జెస్ ఉంటాయి. దట్ మీన్స్ 4 vertices ఉంటే 4 ఎడ్జెస్ ఉంటాయి. ఓకే, నౌ see here in the complete graph that here what is the, suppose ఇక్కడ 6 ఉన్నాయనుకోండి, suppose you can move to 6 vertices, that means here 3, here 3, here 3, total ఎన్ని ఉన్నాయి మనకి? 9. 1 2 3 9 ఎడ్జెస్ ఉన్నాయి. టోటల్గా 9 ఎడ్జెస్ ఉన్నాయి. ఇక్కడ ఎన్ని ఉన్నాయి మనకి? హియర్ అంటే 6 వర్టిసెస్ ఉంటే ఎన్ని ఉన్నాయి? 9 ఎడ్జెస్ ఉన్నాయి. బట్ ఇక్కడ 4 ఉంటే ఎన్ని ఉన్నాయి? 4 వర్టిసెస్, 4 ఎడ్జెసే ఉన్నాయి. సో అవి అంటే 10 వర్టిసెస్ ఉన్నాయి అనుకోండి, అప్పుడు ఎన్ని ఉండొచ్చు? సో ఎలా ఫామ్ చేస్తాము అంటే బై యూజింగ్ సమ్ ఫార్ములా దట్ ఈస్ లైక్ దిస్, n into 10 minus n. That means 10 in the sense number of vertices. Let one set have n vertices and other set, here what is the maximum number of edges in a bipartite graph having 10 vertices. సో ఒక సెట్లో n vertices ఉన్నాయి, అదర్ సెట్లో ఎన్ని ఉండొచ్చు మనకి? 10 minus 1 vertices ఉండొచ్చు. సో టోటల్గా ఎడ్జెస్ ఎన్ని ఉంటాయండి? 10, n into 10 minus n, n into 10 minus n. So differentiating with respect to n, okay, yield as answer that is C, 25. 25 is the answer. Okay. Differentiate 6 అంటే మనకి ఇంకొక సెట్లో ఎన్ని వర్టిసెస్ ఉన్నాయో చెప్పలేదు. వాట్ ఈస్ ద మ్యాక్సిమం నెంబర్ ఆఫ్ ఎడ్జెస్ ఇన్ ఏ బైపర్టేట్ గ్రాఫ్ హ్యావింగ్ 10 vertices. 10 vertices ఉంటే ఒక దగ్గర 10లో డిఫరెన్షియేటింగ్ ఇది ఒక్కసారి చేద్దామండి. అది మ్యాథమెటికల్ ఫార్ములా అప్లై చేయాలి. డిఫరెన్షియేటింగ్ విత్ రెస్పెక్ట్ టు n, yield the answer as 25. నేను ఒకసారి ఇది కంప్లీట్ చేసి ఇస్తాను. సో ఇన్ ద నెక్స్ట్ క్లాస్, ఓఎస్ క్లాస్ కోసం వెయిట్ చేస్తున్నట్టున్నారు. ఇన్ ద నెక్స్ట్ క్లాస్ వీ కెన్ డిస్కస్ అబౌట్ సమ్ ఆఫ్ ద రిమైనింగ్ క్వశ్చన్స్ ఆన్ దిస్ గ్రాఫ్ థియరీ ఓన్లీ. సో ఇక్కడ వరకు నేను మీకు సెండ్ చేస్తాను ఈ 10 క్వశ్చన్స్, నోట్ డౌన్ చేసుకోండి. అండ్ వన్ మోర్ థింగ్, నేను ఈరోజు వరకు ఉన్న ఎగ్జామ్ షీట్స్ ఏవైతే ఉన్నాయో అవి కంప్లీట్ చేసేసి మార్క్స్ పోస్ట్ చేసి మేడంకి ఇచ్చేస్తాను. ఇంతవరకు వెయిట్ చేసిన ఎవరు ఎగ్జామ్ ఇంకా కంప్లీట్ చేయట్లేరు.
కీ పేపర్స్ చేయండి.